Hi, and welcome to this video on differentiation and the quotient rule. Now, the quotient rule is used when we have two functions, one in the numerator and one in the denominator. So basically we have a fraction. So we have a numerator over a denominator. So if we call the numerator n, the denominator d, dy by dx is f of x over g of x. So when we're faced with a problem like this, the rule is called the quotient rule. This is what we use, and basically if we use this terminology with n as the numerator and d as the denominator, the quotient rule says we take the denominator and then the derivative of the numerator minus the numerator multiplied by the derivative of the denominator all over the denominator squared. An interesting point to note is that we do not differentiate the denominator here, we square it, but in the top line we need the derivative of both the numerator and the denominator. Another way of writing this is g f prime minus f g prime all over g squared, if we use this notation. Now, to use the quotient rule, an easy way to do it would be to first find the derivatives of the two functions and write them down, and then just insert them into the rule. For example, if we had y equals x squared over 5, so we find the derivative of x squared and the derivative of 5 squared, write them down. So d by dx, x squared is 2x, and d by dx of 5, which is a constant, is 0. Now we just insert this into our rule, so y equals 5 d by dx x over 2 minus x over 2 d by dx 5 all over 5 squared, and this would equal 5 2x minus the derivative of the numerator, which is 0, and then the denominator, which is 5. No, the numerator, sorry, that should have been the numerator, which is x squared, and all that over 25, and that is the answer. A quick tip: when we're using some of the rules, not particularly the quotient rule, but in some cases it's better if we can get away with not using or going into a complicated rule. So in this case, if we can get rid of the brackets, or we can get rid of the square roots in some way using algebraic manipulation, then it's better. Then we can just apply the power rule. So what do I mean by that? So let's first of all get rid of the brackets. When we multiply out, we get square root of x plus 1 over square root of x, and we're multiplying that by the square root of x plus 1 square root of x. So basically we're squaring. And what do we do when we do that? We use a FOIL method, or as I call it, the claw method. So draw a little claw and then multiply out, and we get y equals square root of x squared plus square root of x 1 square root of x plus square root of x plus 1 square root of x plus the final one, 1 over square root of x squared. Now when we combine the like terms, we get x, square root of x squared is x plus 2 square root of x 1 over square root of x plus 1 over x. When we square 1 over square root of x squared is 1 over x. Now this one cancels this out, and we get x plus 2 plus 1 over x. So dy by dx is equal to 1 plus 0 plus, that becomes a minus 1 over x squared. And when we arrange that, 1 minus 1 over x squared. And that is the answer. Or if you want another form of that, x squared minus 1 over x squared. Be careful with the minus and the plus when we're differentiating 1 over x. Okay, some quick examples of using the quotient rule. So in this case, f prime of x, the derivative, equals 1 minus x, the denominator, the derivative of 2 minus the numerator, which is 2 multiplied by the derivative of the denominator, all over the denominator squared, which equals 1 minus x, derivative of 2 is 0, minus 2 multiplied by minus 1, all over 1 minus x squared. We work that out, 2 all over 1 minus x squared, and that's the answer. This one, if we rearrange, we get 1 over x squared minus x. So f prime becomes the denominator, x squared minus x, multiplied by the derivative of the numerator minus the numerator, multiplied by the derivative of x squared minus x, all over x squared minus x squared. So f prime then becomes x squared minus x, derivative of 1, sorry, that should be 1, is 0, minus 1, 2x minus 1. If we get rid of the brackets here, this becomes minus 2x plus 1. So when we rearrange, so that should be over x squared minus x squared. When we arrange this, we get 1 minus 2x all over x squared x minus 1 squared. And that is your answer. Okay, let's do a quick example using sine x and cos x. So using the quotient rule, we get y prime cos x multiplied by the derivative of sine x, let's put that in brackets, minus the numerator, which is sine x, multiplied by the derivative of cos x. And all that is over cos x squared. So y prime becomes cos x, derivative of sine x is cos x minus sine x, and the derivative of cos x is minus sine x. Be careful with this minus sign, and all that is over cos x squared. Do not get the derivative of cos x squared. Don't differentiate. And this equals cos x squared plus sine squared x all over cos squared x. Now, to tidy this up, we need some trig identities. We know that cos squared x plus sine squared x equals 1. So that's from our trig identities. And also that 1 over cos equals sec. So that's another identity. So using those, we get 1 over cos squared x equals sec squared x. And that is your answer. Let's do some more ones with sine x and also one with e to the power x. Again, just simply insert into the quotient rule, so we get y prime is x squared d by dx sine x, which is the numerator, minus sine x d by dx of the numerator, the denominator, which is x squared. And all that is over the denominator squared. This equals x squared cos x, being derived, getting the derivative of sine x minus sine x, and the derivative of x squared is 2x, and all that is over x squared squared. Rearranging, multiplying out the brackets, we get x squared cos x minus 2x sine x, x to the power 4. And then when we work that out, that equals x cos x minus 2 sine x we can take out a sine x here and an x there from there, so that becomes x to the power 3. So it's x cos x 2 sine x to x to 3. Okay, in this case, y prime cos x derivative of 5e to the x minus 5e to the x multiplied by the derivative of cos x all over cos x squared. Cos x derivative of 5e to the x is 5e to the x multiplied by 5e to the x derivative of cos x minus sin x all over cos squared x. And when we work this out, that becomes 5e to the x. Taking the e to the x is factoring that out. Cos x plus sin x all over cos 2x. And that is your answer. Okay, let's do a slightly more complicated question using the quotient rule. So f prime of x, let's just take it one step at a time. X squared minus 2, which is the denominator, the derivative of 3 root x minus 3 root x multiplied by the derivative of the denominator again, x squared minus 2, and all that over the denominator squared. So when we get the derivatives, we get x squared minus 2 brackets divided by the derivative of 3 root x is 3 over 2x, sorry, let's write this down, x to the minus a half minus 3x to the half, and the derivative here is 2x all over x squared minus 2 all squared. So when we take the x squared minus 2 squared out, we can write that as 1 over x squared minus 2 all squared multiplied by minus 6 x 3 power 2 plus 3x squared minus 6 all over 2 root x. And finding a common denominator here of 2 root x, this then becomes minus 12x squared over 2 root x plus 2 root x 3x squared minus 6, and then we have this on the outside. And then when we work that out, we get minus 9x squared plus 6, 2 root x x squared minus 2 whole squared. And that is your answer.